So today's lesson 67, I'll write this down for a resource, percent of change. And that is going to be on page 452. And this is very similar to some things that we have already started when we've talked about, funnily enough, like the other group with ratios and implied ratios. This is something kind of similar to what we are doing, but we're going to be setting up a ratio total, except for our ratio is going to be a percent compared to the actual price. So when we set these up, we will be making boxes. The only reason why you make the boxes is for organizational purposes. So the first box is percent and the second box is actual. And again, the only purpose of these is for us to be able to organize our information. And we will always organize our information in such a way where we will write original, the original percentage first, and then the change plus or minus second, whatever that change is, plus or minus. It depends on what we're doing and what the problem this is. And then the new. Notice a little crooked. So, but if we keep that order, original, change, plus or minus, if the percent goes up or down, and then what that new percent actually happens to be, allows us to set up a proportion. And I know that's not very straight. So if you went to the store and bought a dress, hopefully not Beck and Joe, and you bought a dress for 30% off, this is what we got going on. The original percent was 100. The change was 30% off. The new percent would be 70. That was a change down, right? It was marked down, not marked up. It was marked down. And that dress on sale was $42. Okay, not a very nice dress. But it was on sale for $42. Okay, that's your percent change. All right? How much did that dress cost originally?
You do 100 over 70?
100 over 70. This is set up just like those other problems that we've done. These are no different except for now we're dealing with percents. So if 100 over 70 equals whatever the variable you want it to be, so x over 42, because that's what we know. That's the only bit of actual information we know.
So 4200 divided by 70.
So that's 4,200 divided by 70 equals x, is how we set it up, which is really 420 divided by 7,
60.
which is, okay, 60. So, very good. So the price of the dress originally was $60, but you picked it up for 42. Okay? Not a bad deal, not great, but not bad. All right? And that's exactly how we will set these problems up when we do these. So I'm going to keep the chart, so that's how I'm going to clear this stuff out here. Let's try a couple more so we know we're right on with this stuff. All right. So original, change, and new. All right, so houses in the neighborhood. Let's say the economy actually changes, so, because right now, the economy's not the best for housing, but I hear some stories from people that work in the housing industry that's changing. But what if next year that the median price of the house in your neighborhood went up 20%? So your original is 100 again. It went up 20%, so that's plus 20%, which means your new is 120. Okay, it's not 80, it's 120, so it went up. And the house value now is 288,000. That's what it is now compared to what it was before that 20% increase. Now here's the question. By how many dollars did it increase? So where is my variable going to be? Under 100 or plus 20? Plus 20, because I want to know how much it increased. I don't need to know the original. So I set this problem up with the information in my chart. That's 20 over 120 equals x over 288,000. Which means I have 288,000 times 20 divided by 120 to solve.
But then you can take off 0 from both sides if you want. So 144,
It would be
144, 0.
What is 120 divided by 20?
6.
120 divided by 20 is 6, right? Okay, so that's gone. This is 6. So it's 288,000 divided by 6. So what is 288 divided by 6?
um, 68,000.
Not 68, look what I just did.
44.
Okay? Not 44, 48, right?
48.
And how many zeros did I have left?
2.
I had
Perfect.
3 zeros left.
Showing up 48,000.
So it went up 48,000. You could do 288,000 times 20 divided by 120. You get the same answer. I was trying to break it down so you didn't have to deal with as many big numbers. So we have to deal with all those big numbers. Sometimes it can get a little bit complicated. Let's try one more. The town's population increased from 80,000 to 90,000 in 10 years. So here's your percent. Here's your actual. Increased from 80,000 to 90,000. So 80,000 went up 10,000, right? So there's your change, and it's 90,000 is your setup. We want to know what the percent of increase is. I have no idea.
100 on top.
100 on top?
Yeah.
What is the percent of increase?
So you do 100 over 10,000,
Well, 100 over x, because
Oh,
this
yeah,
is a
yeah.
blank box.
and then equals 10,000 over 90,000, or 80,000 over 10,000.
80,000 over 10,000. Okay? When I cross multiply, I get some crazy numbers. I get 1 with 6 zeros after it,
Yes.
1,000,000. divided by
40,000?
80,000. Okay, so cross off all my unnecessary zeros, because I can divide 100 divided by 8. So I get 12.5% was my increase.
1.5%.
So my increase, my X is
Was
12.5%. Now down here, I don't need to fill out my chart. The only reason why we have a chart is to organize the information. So the actual, the percent increase total would be 112%, 112.5%. But I was only asked for what was the actual increase. I was not asked what the total increase was. You could write that as 12.5% or 12.5%. Either way, you have it. Any questions on these? These aren't too much different than what you've already done. Except for you just have to set up more stuff. All right, so very good.